Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're talking about solving two-step and multi-step linear equations. I'm going to get right to it, and we're going to see some repeated things from last lesson, which was single-step equations, because the goal is always the same, okay? And the goal, if you remember, is to isolate the variable. Get the variable all by itself. You told us this yesterday. Yes, I know. I'm going to tell it to you for quite some time. We want to solve for x as a positive in the numerator. Okay? That's what we want to solve for. We also have the same exact important note that I gave you yesterday. And that's whatever operation is performed on one side of an equation must also be done on the other side of the equation. Trying to really make you guys understand the goal, what it is you want to solve for, and the fact that solving an equation, like I said yesterday, is like doing weights, okay? You put an even amount of weights on both sides of the weight bar. Or if you're doing a machine, you know, the weight that you put in the machine is distributed equally to both sides of your body. It's like a scale. Put 10 pounds on the left side of the scale, you must put 10 pounds on the right side of the scale for them to balance out. So, yesterday we talked about single-step equations, and we will not be going back to single-step equations. However, as we get more complicated with our equations, y'all, what's going to end up happening is we're going to break down these complicated equations, and we're going to make them eventually a single-step equation. So once we break down these complicated equations to a single-step equation, now you use the single-step equation rules and procedures. So what are the steps for a two-step equation? It's pretty simple. You're first going to undo addition and or subtraction first. So you're going to have something being added to the variable or subtracted from the variable. You're going to get rid of that first. And step two, believe it or not, it's this simple. You undo multiplication and or division second. I'll give you a little hint though. Once you get rid of the addition or subtraction, you're left with a one-step equation. So that should be pretty simple from there, okay? So a two-step equation, you undo addition and subtraction first, and then you undo multiplication and or division second. I say the and or because it could be multiplication or it could be division. All right? Pretty simple, two steps. So some practice on that. Oh, but real quick, before I do that, that's right, I forgot, I added this. Special cases of linear equations. A lot of times teachers don't teach this, and then they get upset at their students for not knowing it. A lot of times books do not mention it, but yet they'll have this in the answer key. And my students will come up to me and say, what does this mean? So I want to put all of that aside, and I want to make sure that I get every single skill that you need for equations. When the variables cancel out, my friends, sometimes you're going to have situations, and we will see this throughout the year, when the variables cancel out, there are no variables left. That's it. It's gone. Bye-bye. See you later. Have a good day. You're going to be left with two options, okay? For example, you'll be left with a true statement, which renders all real solutions or infinitely many solutions. When this occurs, you solve what's called an identity equation. For example, I've got 3x minus 5 equals 3x minus 5. If you could recognize, bless you, if you could recognize that both of those equations are equal from the beginning, even better. But most people don't, and that's fine. Okay, get used to it. Okay, I got to combine the x's, so let's go ahead and subtract 3x to both sides. Oh, wait a second. Plop, plop. I got negative 5 equals negative 5. Is that a true statement? Yes. So this would be all real solutions. Okay? When you have an all real solutions answer, it's because you solved an identity equation. Now, that sounds real pretty, all real solutions. Oh, that sounds really nice. What does it actually mean, guys, in your opinion? Yes, sir, my brother. I couldn't have said it better myself. You can plug in any real number and the equation will read true. That's what all real solutions mean. It means any real number can be plugged in for x, and you're going to get the same value on both sides. The equation will read true with any real number. Does that make sense? Okay. Option 2, you'll be left with a false statement, okay, which renders no real solution. When this occurs, you solve a no solution equation. Here, the 3x's will cancel out, and you're going to be left with negative 15 equals negative 5. Is that a true statement? So this is no solution. I'm not trying to be sarcastic. I do want to make sure you know what this means. What does no solution mean then, guys? What does it mean? Yes, sir. Yep. It doesn't matter what value you put in there for x. It's not going to be true. It's not going to be a solution. So there are no real solutions that make this equation true. There are no real solutions that make this equation work. Okay? So when you're doing your homework, if you get to an answer and you cancel everything out, and let's say you got 0 equals 0, is that a true statement? Yes, so that's all real solutions. If they ask you for what kind of an equation that is, that's an identity. If you get down to the bottom and at the end you find that 0 equals 5, is that a true statement? So that's false. So when it's a false statement and the variables have gone bye-bye, that's no solution, okay? So now you'll know, and hopefully this will help you out a lot. Now let's get to some examples. We've got 5x plus 15 equals negative 10. Well, this is very simple. I'm going to follow my procedures. What is the first procedure that we have here? Yes, sir. Very good. We're going to cancel out addition with subtraction. Good job for all of you. And we're going to get rid of a positive 15 by subtracting 15 to both sides. Absolutely. And now, my brothers, we're just left with a one-step equation. So now in this case, what's the relationship between 5 and x? Are they being multiplied or divided? No, they're being multiplied. But I get you, but you got to divide to cancel that out. So I'm going to divide by 5 to both sides. And x will equal negative 5. Make sense? Okay. Number 2, I got negative 3x minus 8 equals 7. Okay. So I'm going to go ahead and add 8 to both sides to get rid of the subtraction and addition first. It's going to equal 15. What's the relationship between negative 3 and x? Multiplication. How do you cancel multiplication? Division. So you divide by negative 3. Bada bing, bada boom. And x equals negative 5. Yes, sir. Someone told me wait. Yes, sir. If I made number 1 and number 2 equal.
So let's say that was just one problem together. You're trying to figure out if it was, like, I was wondering if that was an example that could ever be an all real number.
Okay, yeah, if you combine equation 1 and 2, you will not have all real solutions. No. All this is saying is that negative 5 is the one that works for here. Negative 5 works for here as well. However, if you combine both of these together, you will not get the same. No. Yes, sir.
It's kind of like a little bit different. So if you had, on one side of the equation, you had 10 plus 5
Okay.
equals 30 divided by 2. Would that be an all solution?
10 plus 5 equals 15, and 30 divided by 2 would be 15. Yes, both sides will be equal. But there the key was you got rid of the variable. If I set up 5x, this is a great question, thank you. If I set up 5x plus 15, okay, equal to negative 3x minus 8, I'm going to add this over. You're going to get 8x equals negative 23. You're going to get a value for x. You know, the only way that you can get a no solution or all real solutions, my brothers, is because the variable goes bye-bye. It disappears. It's gone. And then you're left with only numerical values. And then you can say, okay, is the left side equal to the right side? Is that a true statement? If so, all real solutions. If not, hey, is the left side equal to the right side? No, it's not. No solution. Does that make sense? Thank you so much. Okay. Number 3. Okay, what do we do in this particular case here? We got 12 minus 6x equals negative 18. So what do we do? Yes, sir. You're exactly right. You're going to undo addition subtraction first. So you're going to subtract 12 to both sides. Negative 6x equals negative 30. Yep, divide by negative 6. Thank you, sir. And x will equal 5. Very good. You can always plug this variable back in, by the way, and check your answer. If you have time left over on a test or a quiz or an SAT, and you have equations that you solved, you can always go ahead, plug them back in, and make sure that it works. Okay, how about number 4? What do we got here? What are we going to do here? Yeah, you subtract 15 to both sides. It's very good. Awesome. Very good. And I got negative x equals negative 9. I'm done, right? No, very good. Why am I not done? You're exactly right. It can't be a negative. So how do I get rid of that negative, brother? Nah, you don't add. Nah. No, it just doesn't miraculously become a positive. How? Hold on. Let him do it, guys. How do we do it, my man? No, 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 no. Yes, sir. Thank you. There's an imaginary negative 1 being multiplied here. So what do we do, my man? That's exactly right. You divide by a negative 1. Good try. Thank you for trying, my man. It takes guts to take a risk. Thank you. Good job. Thank you for getting his back. Well done. Okay, now, in this particular case, guys, we got a little bit of a messier situation, okay? We have 6x minus 2 times parentheses 3x minus 5 equals 10. Huh? What? Okay. Remember the distributive property, guys? Okay. Whenever we're dealing with equations, we're eventually trying to break them down to a 2-step equation. Then we're trying to break them down to a 1-step equation. So whenever you have a situation like this that has parentheses, distributive property, you have to distribute first, combine like terms, and then start solving. Yes, sir. Okay, tell me, what do I got? Yep. That's right. Plus 10 equals 10. Okay. Oh, look at what Mr. Morrow did here. 6x minus 6x. Bye-bye. 10 equals 10. Very good, my man. This would be all real solutions. Now, there is a symbol for all real solutions, and just draw a parallel symbol and then a big R. And that means all real solutions. Okay? That's not, I didn't make it up. That's all real solutions, okay? And then how about for this next one, number 6? What do you think we would do here? Yes, sir, my man. Perfection equals 12. Yeah, these go bye-bye. 10 does not equal 12. So this is no solution, no real solutions. There's no symbol for that. Well, yes, there is. Yeah, there is a symbol for that. No solutions could also be written as a 0 with a line through it. That means an empty set or no solution. Just in case you ever see those symbols, you'll know what they mean. All right. Not bad for 2-step, right? Okay, now let's put it all together. Okay, guys, you don't have to write this part again. I know it's in your notes. You can if you haven't, if it hasn't been stuck in your head yet. I'm not here to torture you, though. Why am I doing it? Because I really want to make sure you guys got this. So if this makes no sense to you or at all shaky, write this down again. What's the goal of any equation? Very good. Isolate the variable you want to solve for x. Positive in the numerator. I'm going to continue. I don't want to bore you. Important note. What's the note that we should always remember? Beautiful. Whatever is done on one side must be done on the other side. Excellent. Now, procedure for multi-step equations. Whoa, we got 5? I promise it's not that. I promise it's not that bad. Step 1, very simple. Complete any distributive property first. We had a little tease of that in the last 2 questions that we saw. You see a distributive property, go ahead and distribute it, my brothers. Go ahead and distribute it. Now, once you distribute it, you're going to have all these, terms everywhere. Remember that you have a left side of the equation and a right side of the equation. Please remember that. And since you have a left and a right side of the equation, go ahead and combine like terms on both sides of the equation. Look at the left side, combine like terms there. Look at the right side, combine like terms there. Okay? Yes, sir.
That doesn't affect either side.
Very good. What you do to the left side doesn't affect what you do to the right side in this particular step because you're combining like terms. What I'm meaning there is, let's say after you distribute, you have 2x minus 3x minus 8 equals whatever, x plus 9 plus 15. This left side you can combine like terms and now it's negative x minus 8. This right side you can combine like terms and now it's x plus 6. And then from there you start solving. But when we're combining like terms on both sides, you're combining like terms on both sides. You look at the left side, how do I combine like terms? I'm not trying to be sarcastic, but remember, that's why we learn how to combine like terms. That's why we build the math. Then you look at the right side. Okay, can I combine like terms? You do those first, okay, after the distributive. Thank you, my brother. Very good question. Very good question. I'm very proud of you. Next, now it starts getting easy. Now that you've already distributed everything, you've combined like terms, we got to get all the variables together on one side. The most popular question, which side do we move it to? It does not matter. It's really up to you. Like, really up to you. It does not matter to me. But what does matter, what is important, is you have to move all the variables to one side. Choose a side. Move everything to that. But choose one side. Now, once you move everything to one side, once you move the variables to one side, guys, you have a two-step equation. Now you undo addition, subtraction. And then once you do that, my brothers, you have a one-step equation. And you undo multiplication and division. So it's really nothing that difficult. The key to remember is make sure that you get rid of distributive property first. Combine like terms on both sides. So look at the left side, combine like terms there. Look at the right side, combine like terms there. Then you move the variables to one side. Then you undo addition and subtraction because you have a two-step equation. Then you undo multiplication and division because you have a one-step equation. These steps make sense? So let's get to it. Okay, so for number one here, okay, we have negative 36 equals negative 8x minus 2x minus 6. Hey, do I have any distributive properties that I can distribute? Nah, right? Can I combine any like terms on both the left and or the right side? Yeah. On the left side, I can't do anything. It's just negative 36. But here on the right side, negative 8x and a negative 2x, when the signs are the same, you add and keep the sign. That's negative 10x minus 6. Now, guess what, guys? What kind of an equation do we have? No, we have a two-step. So I'm going to add 6 to both sides. Now I've got negative 30 equals negative 10x. Divide by negative 10. So x equals 3. That's a multi-step equation. Talk to me, guys. If that confused you, if you didn't see what I did, anything you need, I want to make sure you got this down pat. Okay. Number 2, do we have a distributive property? Yeah, so we have to distribute it. Okay, y'all? We have no choice. So this is 28 minus 20w plus 35w equals negative 2. So now, can I combine like terms on both sides of the equation? You can combine the negative 20 and the 35. So what's negative 20w plus 35w? Positive 15w. Yes, sirs. Guess what? Not as bad as you probably thought. Now it's just a two-step equation. So how do I solve, y'all? That's right. You undo subtraction or addition. Then I have 15w equals negative 30. And how do I get rid of multiplication? So since 15 is being multiplied to W, I divide by 15 to both sides, and W equals -2. And again, you can plug this back in if you need. If you ever stress or you say to yourself, this just doesn't look right. This number just, no, it doesn't look right. Plug it back in. You can always check, y'all. Okay, how about number 3? What do we do here? Distribute, absolutely. So you're going to distribute 5 to both the x and the -2. So I've got 5x minus 10 equals -25. Do I have any like terms that I can combine on the left or the right side? No, good. So now I have a two-step equation. So how do I solve this? Add 10, very good, to both sides. Excellent. And then that's going to be, what's -25 plus 10? That's exactly correct. And then how do I solve for x? Divide by 5, yes. X equals -3, very good. Now, you may be saying, just so you guys know, oh man, Mr. Morrow is being nice. He's not doing fractions. I love it. We have a whole lesson just on fraction and decimal equations. So don't worry. Mr. Morrow's not getting soft on you. He just has to, we got to walk before we run. Okay, number 4. 8 equals 3 minus 2n plus 5. Do I have a distributive property that I can perform? Do I have like terms on either and or both sides that I can combine? Okay, tell me. 8 equals, yeah, because 3 and 5 is 8 minus 2n. Now tell me what to do, Bob. That's exactly right. You subtract 8. Now, okay, I am so glad you said that. I am very proud of you. No, you're wrong. But I'm very proud of your wrong answer. I don't know if you heard it in the video or not, but he said no solution. Number 1 go-to answer when you have a variable equals 0. Here's the key, my brother. For it to be all real solutions or no solutions, don't the variables have to go bye-bye? Yeah. There's still a variable here. How do you solve this then? Like anything else. What's the relationship between -2 and n? How do you cancel multiplication? So you're going to divide -2 to both sides, so 0 equals n. No, it's not a no solution, but that's the greatest question we've had today. You know why? Because you're never going to make that mistake on a quiz or a test. Good job, son. You probably helped a lot of people with that question. Good job. Or actually with that statement. That was wrong, but it's all good. All right. Thanks again, though. All joking aside. Good job, buddy. Did that make sense, guys? Don't ever be afraid of just having a 0 there, please, okay? Now, number 5. What do we got to do here? Yeah, you're exactly right. So this is going to be 12. Boo. All right, let's try that again. Okay, we'll try it one more time. So we're going to distribute 6 to the 2x and to the -3. So this is 12x minus 18 plus 5 equals, distribute that -4, -20 minus 15x plus 8. 12. Thank you. Thank you. I was testing you guys. Good job. Yeah. All right. Now we can add like terms on both sides here. Here it's going to be 12x, and then -18 plus 5 is -13 equals -12x, and a -20 plus 8 equals a -12. I got to move things to one side. So what variable do you want to move? I don't care who you want to move. You want to move the 12x to the right or the -12x to the left? I don't care. Okay, so how do I get rid of that -12x? You add 12x. That's exactly correct. So when I add 12x, I'm going to get 24x minus 13 equals -12. Add 13 to both sides. And then that's going to give you 24x equals 1. What's the relation between the 24 and the x? How do you cancel multiplication? So you're going to divide 24 to both sides, and x will equal 1/24. Okay? Make sense, boys? All right, I'm going to do 6 in blue because I know that took a little bit of space. So I've got 12 here plus 2x equals. What's that negative outside of the parentheses represent? A -1. Thank you, gentlemen. So that's negative x plus 6. Who do you want to move, the 2x to the right or the negative x to the left? I don't care. Okay, so let's add x to both sides. Guess what? Now it's Mickey Mouse time. Now I subtract 12 to both sides. 3x equals -6 divided by 3. X equals -2. Not too bad, right? Okay. Okay, for number 7, I'm not going to say what I'm going to do out loud. Of course, I'm on a video. I'm going to be doing it right now. You'll be able to see me. Do your best not to look at what I'm doing right now on the board, guys, and do it on your own. Okay, let's do this. I'm going to be quiet right now. Go. Okay. My answer was 16/29. You may not be there yet. That's okay. But let's see if you got it. Let's see if you got it. Okay, I hear a yes over here from one of my boys. Awesome. Awesome. I like that. I like yeses. How about the rest of you guys? You got that? Well, if you didn't get it, then go back. I was silent, but I went step by step. Have a wonderful day. I'm going to do this last one for you real quick. And please watch it because it's simple. If you want, I'm going to do it now anyways. Go ahead and go to lunch as quietly as possible. Thank you again for watching. Hope you learned a lot. For this one, I got 6x minus 4x. A lot of people get freaked out here. All you need to do is combine the x's to one side. So I'm going to add 4x to both sides. And I've got 10x equals 0. Divide by 10. So x equals 0. It's that simple. Thanks again, y'all. Have a great day. I hope you learned a lot. Bye-bye now.